Key events in the Cambrian view discuss edit -550, -540, -530, -520, -510, -500, -490, NEOPROTERO ZOICPALEO. ZOIC Ediacaran C AMBRIAN Ordovician T ERENEUVIAN SERIES 2 SERIES 3 FURANGIAN Fortunian. Stage 2, Stage 3, Stage 4, Stage 5, Drumian Guzhangian Paibian Jiangshanian. Stage 10, asterisk 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 Baykonur glaciation asterisk 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 Orsten, Fauna Burgess Shale, Kaili biota Archaeocyatha extinction Emu Bay Shale Sirius Passet biota Chengjiang biota First Trilobites SSF diversification. First brachiopods and Archaeocyatha First halkieriids, mollusss. Hyoliths SSF Treptichnus pedum trace large negative peak delta 13 ccarb excursion First Cloudina Namacalathus mineral tubular fossils stratigraphic scale of the ICS subdivisions and Precambrian Cambrian boundary. The Cambrian is the first geological period of the Paleozoic Era, lasting from 541 to 485.4 million years ago, and is succeeded by the Ordovician. Its subdivisions, and indeed its base, are somewhat in flux. The period was established by Adam Sedgwick, who named it after Cambria, the Latinized form of Cymru, the Welsh name for Wales, where Britain's Cambrian rocks are best exposed. The Cambrian is unique in its unusually high proportion of larger strata sedimentary deposits. These are sites of exceptional preservation, where soft parts of organisms are preserved as well as their more resistant shells. This means that our understanding of the Cambrian biology surpasses that of some later periods. The Cambrian marked a profound change in life on Earth. Prior to the Cambrian, the majority of living organisms on the whole were small, unicellular and simple, the Precambrian Charnia being exceptional. Complex, multicellular organisms gradually became more common in the millions of years immediately preceding the Cambrian. But it was not until this period that mineralized, hence readily fossilized, organisms became common. The rapid diversification of life forms in the Cambrian, known as the Cambrian Explosion, produced the first representatives of all modern animal phyla. Phylogenetic analysis has supported the view that during the Cambrian radiation, metazoa evolved monophyletically from a single common ancestor. Flagellated colonial protists similar to modern choanoflagellates. Although diverse life forms prospered in the oceans, the land was comparatively barren, with nothing more complex than a microbial soil crust and a few mollusks that emerged to browse on the microbial biofilm. Most of the continents were probably dry and rocky due to a lack of vegetation. Shallow seas flanked the margins of several continents created during the breakup of the supercontinent Pannotia. The seas were relatively warm, and polar ice was absent for much of the period. The United States Federal Geographic Data Committee uses a barred capital C character similar to the capital letter Ukrainian E to represent the Cambrian period. The proper Unicode character is U+A 792 Latin capital letter C with bar. Stratigraphy. Despite the long recognition of its distinction from younger Ordovician rocks and older Precambrian rocks, it was not until 1994 that this time period was internationally ratified. The base of the Cambrian is defined on a complex assemblage of trace fossils known as the Treptichnus pedum assemblage. Nevertheless, the usage of Treptichnus pedum, a reference at no fossil for the lower boundary of the Cambrian, for the stratigraphic detection of this boundary is always risky because of occurrence of very similar trace fossils belonging to the Treptichnids group well below the T. pedum in Namibia, Spain and Newfoundland, and possibly, in the western USA. The stratigraphic range of T. pedum overlaps the range of the Ediacaran fossils in Namibia, and probably in Spain. Subdivisions. The Cambrian period follows the Ediacaran and is followed by the Ordovician period. The Cambrian is divided into 4 epochs or series and 10 ages or stages. Currently only 2 series and 5 stages are named and have a GSSP. Because the international stratigraphic subdivision is not yet complete, many local subdivisions are still widely used. In some of these subdivisions the Cambrian is divided into 3 epochs with locally differing names: the Early Cambrian, Middle Cambrian and Furonian. Rocks of these epochs are referred to as belonging to the Lower, Middle, or Upper Cambrian. Trilobite zones allow biostratigraphic correlation in the Cambrian. Each of the local epochs is divided into several stages. The Cambrian is divided into several regional faunal stages, of which the Russian Kazakhstan system is most used in international parlance. In Russian scientific thought, the lower boundary of the Cambrian is suggested to be defined at the base of the Tomotian stage, which is characterized by diversification and global distribution of organisms with mineral skeletons and the appearance of the first Archaeocyatha bioherms. Cambrian dating. The time range for the Cambrian has classically been thought to have been from about 542 million years ago to about 488 Maya. The lower boundary of the Cambrian was traditionally set at the earliest appearance of trilobites and also unusual forms known as Archaeocyathids, that are thought to be the earliest sponges and also the first non-microbial reef builders. The end of the period was eventually set at a fairly definite faunal change now identified as an extinction event. Fossil discoveries and radiometric dating in the last quarter of the 20th century have called these dates into question. Date inconsistencies as large as 20 million years are common between authors. Framing dates of California 545 to 490 Maya were proposed by the International Subcommission on Global Stratigraphy as recently as 2002. A radiometric date from New Brunswick puts the end of the Lower Cambrian around 511 Maya. This leaves 21 Maya for the other 2 series epochs of the Cambrian. A more precise date of 542 plus or minus 0.3 Maya for the extinction event at the beginning of the Cambrian has recently been submitted. The rationale for this precise dating is interesting in itself as an example of paleological deductive reasoning. Exactly at the Cambrian boundary there is a marked fall in the abundance of carbon-13, a reverse spike, that paleontologists call an excursion. It is so widespread that it is the best indicator of the position of the Precambrian, Cambrian boundary and stratigraphic sequences of roughly this age. One of the places that this well-established carbon-13 excursion occurs is in Oman. Amthor describes evidence from Oman that indicates the carbon isotope excursion relates to a mass extinction. The disappearance of distinctive fossils from the Precambrian coincides exactly with the carbon-13 anomaly. Fortunately, in the Oman sequence, so too does a volcanic ash horizon from which zircons provide a very precise age of 542 plus or minus 0.3 Maya. This new and precise date tallies with the less precise dates for the carbon-13 anomaly, derived from sequences in Siberia and Namibia. Paleogeography. Plate reconstructions suggest a global supercontinent, Pannotia, was in the process of breaking up early in the period, with Laurentia, Baltica, and Siberia having separated from the main supercontinent of Gondwana to form isolated land masses. Most continental land was clustered in the southern hemisphere at this time, but was gradually drifting north. Large, high-velocity rotational movement of Gondwana appears to have occurred in the early Cambrian. With a lack of sea ice, the great glaciers of the Merino and Snowball Earth were long melted. The sea level was high, which led to large areas of the continents being flooded in warm, shallow seas ideal for thriving life. The sea levels fluctuated somewhat, suggesting there were ice ages associated with pulses of expansion and contraction of a south polar ice cap. Climate. The Earth was generally cold during the early Cambrian, probably due to the ancient continent of Gondwana covering the South Pole and cutting off polar ocean currents. There were likely polar ice caps and a series of glaciations, as the planet was still recovering from an earlier snowball Earth. It became warmer towards the end of the period, the glaciers receded and eventually disappeared, and sea levels rose dramatically. This trend would continue into the Ordovician period. Flora. Although there were a variety of macroscopic marine plants, no true land plant fossils are known from the Cambrian. However, biofilms and microbial mats were well developed on Cambrian tidal flats and beaches, and further inland were a variety of lichens, fungi and microbes forming microbial earth ecosystems, comparable with modern soil crust of desert regions, contributing to soil formation. Fauna. Most animal life during the Cambrian was aquatic, with trilobites assumed to be the dominant life form, which has since proven to be incorrect. Arthropods in general were by far the most dominating animals in the ocean, but at the time, trilobites were only a minor part of the total arthropod diversity. What made them different from their relatives was their heavy armor, which fossilized far more easily than the fragile exoskeleton of other arthropods, leaving behind numerous preserved remains which give the false impression that they were the most abundant part of the fauna. The period marked a steep change in the diversity and composition of Earth's biosphere. The incumbent Ediacaran biota suffered a mass extinction at the base of the period, which corresponds to an increase in the abundance and complexity of burrowing behavior. This behavior had a profound and irreversible effect on the substrate which transformed the seabed ecosystems. Before the Cambrian, the seafloor was covered by microbial mats. By the end of the period, burrowing animals had destroyed the mats through biotubation, and gradually turned the seabeds into what they are today. As a consequence, many of those organisms that were dependent on the mats went extinct, while the other species adapted to the changed environment that now offered new ecological niches. Around the same time there was a seemingly rapid appearance of representatives of all the mineralized phyla except the brachiopods, which appear in the lower Ordovician. However, many of these phyla were represented only by stem group forms, and since mineralized phyla generally have a benthic origin, they may not be a good proxy for non-mineralized phyla. While the early Cambrian showed such diversification that it has been named the Cambrian Explosion, this changed later in the period, when it was exposed to a sharp drop in biodiversity. About 515 million years ago, the number of species going extinct exceeded the amount of new species appearing. 5 million years later, the number of genera had dropped from an earlier peak of about 600 to just 450. Also, the speciation rate in many groups was reduced to between a fifth and a third of previous levels. 500 million years ago, oxygen levels fell dramatically in the oceans, leading to hypoxia, while the levels of poisonous hydrogen sulfide simultaneously increased, causing another extinction. The later half of Cambrian was surprisingly barren and show evidence of several rapid extinction events. The stromatolites, which had been replaced by reef-building sponges known as Archaeocyatha, returned once more as the Archaeocyathids went extinct. This declining trend did not change before the Ordovician. Some Cambrian organisms ventured onto land, producing the trace fossils Protechnites and Climacticnites. Fossil evidence suggests that Euthocarcinoids, an extinct group of arthropods, produced at least some of the Protechnites. Fossils of the maker of Climacticnites have not been found. However, fossil trackways and resting traces suggest a large, slug-like mollusk. In contrast to later periods, the Cambrian fauna was somewhat restricted. Free-floating organisms were rare, with the majority living on or close to the sea floor, and mineralizing animals were rarer than in future periods, in part due to the unfavorable ocean chemistry. Many modes of preservation are unique to the Cambrian, resulting in an abundance of lagerstätten. Stromatolites of the Picker Formation near Helen Lake, Banff National Park, Canada. Trilobites were very common during this time. Anomalocaris was an early marine predator, among the various arthropods of the time. Paikia was an early chordate from the Middle Cambrian. Opabinia was a creature with an unusual body plan. It was probably related to arthropods. Protechnites were the trackways of arthropods that walked Cambrian beaches.